Okay, welcome back to this series where we try to follow this book, Crafting Interpreters. And last time we kind of made it to here, but there were some things that weren't working so well. So one thing was that this print statement didn't flush before we got down to here, which was a little bit annoying. We tried to call flush, but it didn't work. But now it works because we import the right trait, which you need to call flush. Now that we have the right trait, we can call flush and std out, and it can fail, so we have to handle the error case. But now we have everything we need. We print, we flush it, we read into we read what the user inputs, and then we return it to them. So now the code looks like this. Hello, you wrote hello. So we have a read, kind of fake evaluate and print. It's not a loop yet, so let's make it a loop. Like that. And then we want to say if we need some kind of condition to quit. So let's say that actually this handle returns how many bytes are read, something like that. So let's say if n equals 0, then we just return an OK. Otherwise, nothing. Let's try that. Hello, hello again, and then it doesn't work. Let's also all the time print n equals, and now we can use the debug macro. Let's debug n. Hello, n equals 6. If you do nothing, n equals 1. And before any, so it's like there's always an end of line character. So let's say if n, something like that. Now we should get it to work. Hello. And if we don't do anything, we exit. Okay, so now we also have the loop part of it working. So let's continue reading the book. Readline function reads a line from input, returns result. To kill an interactive command line app, usually type Control D. So let's see if that also works with our thing, because maybe let's continue to debug n here, because I think, oops, cargo wrong. I think that Control D returns 0 exactly. So we can, with this less than or equal to 1, we can either just press enter, or we can press Control D. Perfect. So signals an end of file condition to the program. When that happens, readline returns null, so we check for that to exit the loop. But the prompt and the file wrappers are thin wrappers, and file run are thin wrappers around this core function. Okay. So let's start to implement this guy. Apparently we're going to need a scanner struct. Now it would make some sense to put that in a separate module. Let's do this. Let's not do that. Make a new file. And in here we make a public struct. We need a scanner, evidently. let's make it empty for now. And then we can say, let's just make a new function. Then we can say make a scanner. We call a function called scan tokens. And it wants a source term as input, which we don't use for now. It should return a list of tokens. And that means we need to define a token struct or token type. Could be it's an enum. But then we say scanner, scan tokens, and here we give the contents. And then for token and tokens, we do print. We do a print. And finally we return OK. Can I get away with doing this? Double check. I'm not really sure, how do you get an empty OK? I will look into that. Oops. For now we do that. So how could this fail? It could fail in here, right? So probably this thing should be a result of token or a message. And then in here we just do this automatic unwrapping thing. And there's a warning here that says use loop. Don't mind if I do. Unreachable expression. Yes, good. Now we got something relatively clean. So, not super useful since we haven't written the interpreter, but baby steps indeed. Right now it prints out the tokens our forthcoming scanner will emit so we can see if we're making progress. While we're setting up another thing, another key piece of infrastructure is in error handling, but we've already done that quite a lot. Everywhere we think something can fail, we just use a result thing, and that result thing will kind of propagate up here. So we're doing some explicit error handling, you could say, instead of throwing exceptions. But whatever. Textbooks sometimes gloss over this because it's more a practical matter than a formal computer science problem. But if you care about making a language that's actually usable, then handling errors gracefully is vital. So something that's nice about Rust is the error messages. And so let's say we want to emulate that and have really nice error messages that tell you exactly where the problem is, then it's probably a good idea that we return string from all of these things. Especially in here, because it reaches some tokens that it cannot read, then it can say exactly on which line and whatnot it's going wrong. The tools our language provides for dealing with errors make up a large portion of the user interface. Indeed, when the user's code is working, they aren't thinking about our language at all. The headspace is all about their program. It's usually only when things go wrong they notice our implementation. It's also to understand what went wrong. Okay. I think this is not so interesting for us because the way we've written it, our errors will always just propagate up here. And we will most likely make this look a little bit better, but we don't need this kind of thing. Okay, so you have to remember that the book is in Java, so there has to be a class wrapping everything. But that just means it would be something we put in main if it was a proper programming language. I mean, again, having this flag is a little bit meaningless because it's kind of built into the type of these functions that we made. And again, we just do a match on the result and here's a good point. So in the interactive loop, if there's a mistake, then we shouldn't just exit out. So basically here, instead of saying you wrote something, actually probably it is nice to see it. Let's keep the echoing for now. We can even write echo. And then we want to run what's in the buffer. But if it fails, so if it's okay, we don't do anything. If it fails with some message, then we want to print the message and basically just keep going. So I think it will not work because it will panic because the run function is not implemented, or the scan tokens is not implemented. So panics will still propagate out, which I think is good, but like handled errors will not break it. So instead of starting. I don't know. He says ideally we would have an actual abstraction, some kind of error reporter interface that gets passed to the scanner and parser, so we can swap out different reporting strategies. Yeah, I mean, I only see it in like super specialized cases where you would want a different reporting strategy. Like, let's say you're like running on a supercomputing cluster, so your script is running on 24 different machines. Then maybe you don't want them all to print out or something like that. But it's true, you could do that. But I think it's a little bit overthinking it at this stage. It's fine just to print. It's also what he says. Once you have a scanner class with scan tokens method, we can start running. Before we get to that, let's get more precise about what tokens are. Yes, great. Our job is to scan through the list of characters and group them together into the smallest sequence that still represents something. Each of these blobs of characters is called a lexeme. In that example line of code, the lexemes are var language equals logs, semicolon. Great. Are only the raw substrings. However, in the process of grouping character sequences into lexemes, we also stumble upon other useful information where we take the lexeme and bundle it together with our data. The result is a token. Includes stuff like token type. Okay, let's get started. So, as we expected, the enum is the token is an enum. Can I do that in Rust? Yeah, that was fine. There we have it. So I'm betting if I do format, it will not work. It will do this, which is fine, I guess. So single char tokens. One, two. Right. Literal values, just like strings you put in or numbers directly. Living runtime. Okay, back when I was teaching the gospel about error handling, we saw that we need to tell users where errors occurred. Tracking starts here. Okay, so I actually agree with making it token type. And then we will make a struct called token, which for good measure we will also derive debug on that. And it should have t-type. I'm gonna forget that all the time. So we'll have a token type, lexeme, literal. So, that's interesting. So here he has an object class, just an object. So it probably means that the literal will be either just a string or it will be a number or something. So I would like to do something like this. It can be, it can be number value, which is a guess we only support floats for now. No, okay, so it can be a could be an int value, could be a f value, could be a string value, it could be an identifier value, and I think that's it for now. And then we say the literal is a literal value. Now, will this compile? Okay, it doesn't like all of this. If I do, okay, so I can just run it through like that. Right, and it doesn't like fake snake case. Okay, now it's just complaining. But thing has never been constructed, but I think that's fine. And we should also have line number, which can actually be unsigned, that's never negative. And then there's a new function which should take a token type, a lexeme, a literal, and I mean, it's not necessarily a literal, the token value, so let's say it's an option type for now. And finally, a line number, and then we just plug those in. Oops. So up here in option we have wrong one. Is there any errors? No errors. Okay, so now we've worked a little bit more. We've set up some basic definitions, and I guess in the next one we're looking at how exactly to get these tokens out of just the raw stream of characters that we get from the file or the standard input. Okay, until next time.